Welcome to our first video on logarithm properties with sums, multiplication, subtraction and division, and powers. So we'll go through a couple of overviews right here from previous properties. So remember we had different log forms and exponential forms of some of these properties. So in log form, log base b of 1 is always 0, log base b of b is always 1, and log base b of b to the x is always x. The exponential forms, remember, if I have a log, I can rewrite this as the base to this power over here equals the stuff inside the log. So I get b to the 0 equals the 1 that's inside this log. Also, if I have log base b of b, that's always equal to 1 because I can rewrite this in exponential form. B to the first power is always equal to b. This log form here, log base b of b to the x equals x. I take that base b, raise it to the x power from on this side, and that equals the inside of the log b to the x. So b to the x is always b to the x. So these exponential forms are the most obvious, and then we convert those to log forms to see some of these log properties over here. The last one here, the log form is more obvious. Log base b of x is log base b of x. That should always be true. And now if we convert it to exponential, I'm going to take this base b, raise it to this other side. So I get b to the log base b of x always equals the inside of that log, the x. So that's another property right there. So these first three in the log form, log base b of 1 is 0, log base b of b is 1, and then especially log base b of b to the x equals x. We'll use those sum. And then b to the log base b of x equals x. So that's another one that we can get in the exponential form. So those are some that you should know. If not, go ahead and write those down. You will definitely need those later on. Maybe not in this video, but in some future videos. But there's more log properties that we're going to talk about today. So these are the ones that we're going to investigate today. Log base b of x times y is the log base b of x plus log base b of y. Log base b of x over y is log base b of x minus log base b of y. So product inside becomes a sum. Division inside becomes a difference. And then the last one, log base b of x to the r, is r times log base b of x. So where these come from are the exponential properties. So I just have those over here on the side. So remember, the exponential property, b to the u times b to the v, if I'm multiplying exponentials with the same base, I can add the exponents. So if we think of logs as exponents, really that's what I'm doing here, is I'm adding these exponents, just written in log form. If I have a division of exponentials, I can write that as b to the u minus v, so just a difference of those exponents. So same property here, if I get a division inside the log, that's just a subtraction of those logs on the outside. And then the last one, if I have an exponential raised to another exponent, that's the same as taking that exponent times the other one. So multiplying those two, same thing over here. If I have an exponent inside this log, then I can go ahead and think of this as multiplying that exponent times the entire log. So those are the properties we're going to look at today in expanding and condensing these formulas. Alright, so here's the first type we're going to look at, right as a single log. So if I want to take this expression and condense it down to a single logarithm, I'm going to want to try to use these properties to get just one log at the very end. So the first thing I notice, I have this 2 and this 6 out front that I can go ahead and rewrite using property 3. So using property 3, that 2 is now going to become a square on the y, and the 6 is now going to become a 6 power on the z. So we got log base 3 of y squared plus log base 3 of z to the 6th. What we can do next is use our sum to product rule. So sum of logs is going to be a product inside the log. So if I have these things added outside, now I'm just going to multiply those inside. So that y squared and that z to the 6th will now be multiplied inside the log. And so we just get log base 3 of y squared times z to the 6th. And really that's it for this type of problem. So log base 3 of y squared times d to the 6th, that's my final answer. Notice I do have a single logarithm, it's a base 3, and then a whole bunch of stuff inside. So the main thing though is that I only have one log involved with this answer. Here's the next one. Same directions, right as a single log, but this time we have a subtraction in here. So I can start this the same way. I'm going to take these numbers out front, the 3 and the 1/2, and rewrite those as powers on each of these variables. So that 3 is now going to become a power of x, so we got x to the 3rd. The 1/2 is now a power of t, so I got t to the 1/2. Now I can use the division property. So if I only have 2 logs here, I can go ahead and rewrite that as a division. Alright, so that subtraction becomes a division inside the logs, and we'll get log base 5 of x cubed, the positive part of the log, over the log base 5 of t to the 1/2. So that t to the 1/2 goes underneath since it's had a negative out front. So now we get log base 5 of x cubed over t to the 1/2. Really, you could leave it like that. That would be an acceptable answer. A lot of times, though, they'll convert these fractional powers into roots. So that 1/2 we could also think of as a square root. And so log base 5 of x cubed over the square root of t would also be an acceptable answer. And that's probably the answer they're going to have in the back of the book. Alright, this one's a little trickier, so we want to rewrite this as a single log again. So log base 9 of 4x minus 2 log base 9 of x minus 3 plus 3 log base 9 of x plus 1. Alright, so the first thing I'm going to do is use that exponent rule again. So these numbers out front are going to become exponents. So notice that 2 is now a power of x minus 3. That 3 is now a power of x plus 1. Alright, so after I've rewritten those coefficients as powers, what can I do next? So I see I have some divisions and additions, subtractions and additions. So I'm going to go ahead and rewrite those with all of my additions in one area, all of my subtractions in the other area. The reason for that is that anything that's being added as a log, that's going to go in the numerator. Anything that's being subtracted, that's going to go in the denominator. So if I think of both of those in the sum are going to be in the numerator of my log, and this other one that's being subtracted, that's going to be in the denominator of my log. So this log base 9 of 4x, log base 9 of x plus 1 cubed, minus log base 9 of x minus 3 squared, both the 4x and the x plus 1 cubed, those are both with positive logs, so those will both be in the numerator of this fraction here. This x minus 3 squared, that'll be, that's in a subtracted log, so that's going to be in the denominator. So anything that's in a log being added, that's going to go in the numerator. Anything being subtracted, okay, if this is all expanded out, is going to be in the denominator. So that'll be my final answer for that one. Next time we'll look at going the other way, so taking something like this and then expanding it out into its separate pieces. But for now, that'll do it for writing things as a single log.